Good evening.
Hello, Ayan. How are you?
I'm good, thanks. What about you?
I'm good. Did you forget that you had class or you are busy today?
No, I actually forgot about it. And then you texted to the group chat and I remembered.
Hmm. Okay. Is everything okay?
Yeah, actually, I forgot because we were on holiday, so I thought that we're not gonna have class. So, yeah.
Good. So, are you ready now? Are you fresh or tired?
No, I'm not tired. Usually, I'm tired after school, but we didn't have school today.
Hmm. Good. Ayan. If you're ready, let's say a few questions, and after that, we will see. Maybe others also forgot. Maybe they are somewhere else because, as I heard, you are in the mood of Nowruz celebration, right? And people are visiting their relatives and traveling to other countries. I don't know. And let's see, because they didn't tell me to cancel the class. That's why we're going to have class here. So, Rifah is also joining now.
Hello, hello, Mr. Kasim. How are you?
I'm great, Mr. Rifah. How are you?
Thanks.
In
Sorry,
here,
bro, for being
now it
late.
is mango season. Now everywhere people are selling organic mangoes, and mangoes are so cheap here, only $50, even less than that, 1 kilo.
Here, mangoes are so expensive.
Yeah, because you have 4 seasons, but here mango, pineapple, I don't know, these fruits are very cheap.
Yeah.
So Rifa, I hope you are enjoying your holiday, and so you don't have school, and I hope you are not tired today. So we are going to solve very important questions, and we have only 2 papers left, okay, for practice. And after that, we will solve maybe practice similar but a bit different questions. As you see, this one is 2016 S1. After we finish this paper, we will practice 2016 S2. And after that, 2017 papers, 2017 S1 and S2. And after that, we will have only 1 week left to Sasmo, and let's see. After that, maybe we'll do some revision or practice against some similar questions. So today is 24, right? 24th of March, 2021. As you remember, we started this already. We did a few questions from this paper last time. So we will continue from where we stopped. Okay. Last time we stopped this question. Ayan, Rifa, do you remember this question?
Yes, you told us that if we have any solutions, we should let you know.
Did you have any solution?
No, last week I was thinking about that. I didn't figure out something.
Me too.
Did you?
Yes, later I was thinking and I have some idea and I thought it works. So I got, actually we were solving with different group and they told me some idea. When they were discussing, then immediately I had an idea and we got a solution. So what is the rule here? It's a bit tricky one. Maybe if you can see, it's a little bit hard. But if you can see also that it's quite easy. But here what's going on here is, you see, 2 times 5, right? If we just multiply this number, what's going on here? The first one is 2 times 5, and we are adding 2 here. That's equal to 12. And the second one is 3 times 9, and plus what we have here, that's 27. 27 plus 6 is 33. And here we have 4 times 3 plus 12 is 24. And here we have 5 times 9 plus 45. 20 is equal to 65. But if you just look at these numbers, actually these are familiar numbers. What are these numbers? We have seen them before. They're just the product of 2 consecutive positive integers, or simply 2 consecutive natural numbers. For example, 2, right? I can write 2. Let me just write here 2 is 1 times 2. 6, it is 2 times 3. And 12, it is 3 times 4. And here we have 20, it is 4 times 5. So the next number will be then 5 times 6, it will be 30. That is 5 times 6. So if you just continue this pattern, next one will be 6 times A plus 5 times 6. That's
But
equal to 96.
can I ask a question? Why you do like +2, +6, +12, +12, +20? Why these numbers? Why not others?
No, because if you multiply these two numbers, 2 times 5, and after that, what number should I add to get 12? To the first one, I should add 2. If you multiply 2 and 9, what number should I add so that I can get 33? It is 6. And next one, if you multiply 4 times 3, and what number should I add to 4 times 3 so that I can get 24? That is 12. And for the next one, 5 times 9. So if I add 20, and we have 65. I'm just making an observation, okay? So I'm not getting anything. It's not based on it. I'm just making some observation. I'm just trying to see any pattern. Is there any pattern or not? So at the time here, if you just solve this for A, it will be 96 minus 13. That is 66 is divided by 6. That's equal to 11. So here A should be 11. So now usually this operation, okay, that one is the kind of operation. We call this operation math, all right. So you should be able to define this very clearly. Now, what is the rule here? If you're given any two numbers, then A and B. So what is the operation doing here? It is just we need to multiply A by B and plus just add the product of two consecutive numbers. Now here N is changing from 1, 2, 3, 4, continue. That is the rule here. To get the first one, N equals 1. To get the second one, N equals 2. Third one, it is 3.
Okay.
Good. And how about this? Rifa, can you read the question? It must be very easy for you.
Yeah, I solved this one and I got C.
How did you solve it?
I didn't solve, I just demonstrated it to myself.
I mean, how did you find it? Did you draw this on a paper or did you just put a mirror or what did you do?
No, I didn't in my mind.
Yeah.
Yeah.
Ayan, how about you? Do you agree with Rifa?
Yeah, I agree with him.
Because usually what's going on here is it's just the reflection of this one, right? So this one is the line of the symmetry. Usually to do this one, how do you reflect this? We don't have to reflect the whole thing. You just reflect 2 points, maybe their endpoints, and after that draw a line segment, and you can just see the reflection of those figures. For example, this point and this point, right? If you reflect this point will be reflected on here. And this point will be somewhere here. So now if you just join these lines, it will be the reflection of this line. And the second one, right, this big line, so just I need to join this one, right? If you just join, this means that we just reflected now
Hello,
big.
Mr. Kasim. Sorry for being late.
Hi, Murad. So this one will be here. And this one, big one, will be here, right? So the answer is C. Murad, we have just started. That's our second question. Okay, we just continue solving this paper that we started last time. And let's continue. Ayan, can you read the question?
There are 11 regions in the diagram on the right. Each region is to be painted with one color. What is the least number of colors needed to paint all the regions so that any two adjacent regions don't share the same color?
This kind of question, if you have tablet or iPad, and if you can just see this, if you can write a note on it, it would be great. Or you should do this on a paper. Otherwise, just look at the screen, it may be a bit hard. Anyway, Ayan, did you understand the question?
Well, sort of.
Here, as you see here in the picture, it's just like circles, right? We just divided them into some regions, right? So now suppose that we have a kind of map here, okay? And our task is we need to use minimum number of different colors. Okay, like world map, for example, if you look at the world map, also actually they use minimum number of colors so that no any two countries who share their borders do not have the same color. Right? But different countries like maybe Azerbaijan and some country in the Europe, they may have the same color. But if they are sharing their border, they cannot have the same color. That is the idea actually behind this. Okay. So the question is minimum, because it says the least number. Minimum, we need to find the minimum number of colors needed to paint all the regions so that any two adjacent regions do not share the same color. Adjacent region means the shading, right? Okay, guys, think. Okay, try. Let me give you like 2 minutes or 1.5 minutes. Let's say 1 minute and 50 seconds. And after that, we will discuss together. Rifa, do you have any answer?
No, at home I was trying to do it, but I was confused. I couldn't do it.
Ayan, how about you?
I think it's 5.
5.
Yes.
Mr. Murad, how about you?
No.
Okay, how did you do that, Ayan? Are you just guessing or did you really color them or just number them with different colors?
I didn't color them, but I drew it on a paper. Instead of colors, I just wrote like 1, 2, 3. And at the end, I have numbers up to 5. So it's like 5 colors.
Where did you start one, Ayan? From the middle?
No, I started from the outer layer.
It's just from the middle, actually. As you see here, the middle part, why it's bordered to a lot of regions. So suppose that we have a lot of different colors. Let's say this one is different color number 1, color number 2, color number 3, color number 4, color number 5. Let's see. So first, I just use color 1 to paint here. And after that, I can start from anywhere because they are symmetric, right? And that means that here, this should be, it cannot be 1, so it should be 2. So if it is 2, this one, right, it cannot be 1, it cannot be 2, it must be different. Let's say this, I use color 3. But now this region, it's just bordered to 1 and 3, so it can be 2. I don't have to use new color here, so it can be 2. And how about here? It can be 3, right? It's not bordered to this 3 part. It's only bordered to 1 and 2. And how about here? I can use again, what is it? So as you see here now, I cannot use 1 here. I cannot use 2 or 3 because it's bordered to 2, 1, and 3. So I must use new color here. It is 4. So now here we have 4, 2. I can use 3 here. 2, 3. I can use 1 here. 3, 2. I can use, for example, 4 here. 2, 3. I can use again 1 here. And 3, 4. I can use 2 here. So how many colors, different colors I use here? Only 4. So none of any two regions, they have adjacent regions, right? Or any two adjacent regions, they don't share the same color or they don't have the same color. What do you think, Ayan? Do you agree with me or?
Yeah, I do.
So the answer is actually minimum, we need to use 4 different colors. Less than 4, it's not possible. You can try less than 4, it is not possible. Okay then.
I had 5 because I started from like the outer layer. So then when I got to the middle, I couldn't use any of the numbers, so I had to put 5. So yeah.
Okay, actually we must have the same solution even if you start from anywhere, Ayan. Like for example, let me just try, Ayan, here. Actually, you got the answer. Where did you start? Can you tell me? From the top or here? Where? 1, 2, 3, 4. Where did you start? Tell me the number. 1, 2, 3, 4, 5.
So the place where your eraser is, for there, I didn't start from there. I started from the place where 4 is. I wrote 1 there.
Okay. All right. Good. So here you use the first color, right? It is 1.
Yes.
Then, so
And
here it should be 2, right? Because border, and it should be 3. I cannot be the same. So now if it is 2, I can write here 3.
yes.
Right? So if it is 3, I can write here again 1. It's 1, I can write here 2, right? And 2, here 1, 2, it should be 3. And the 3, and this should actually 3, 2, this should be 1. And 3, 1, it should be 2, right? And if it's 1, 2, again, this should be 3. But this cannot be 3, right? Because here I have already 3. Here it cannot be 2, it cannot be 1. So instead of this 3, how about if I write 4? Then it can be 3 here. Then it can be 1, not 2, not 3. So it can be 2, 3. I can write here number 4 again.
But you see in the middle, now you have to put 5 because there's 1, 2, 3, and 4. So you can't use any of them. So that's why I have 5 there.
That's right. I see. Yeah, now I got it. So now what is our conclusion? So that means that we need to start from somewhere that is bordered to most number of regions.
Yeah.
At the time, I think you will reach the same solution. You are right. Okay, that's why I think you got stuck here. But if you start from the middle here, right, and 1 at the time, maybe it is 2, 3. This would be, let's say it can be 3 here, but this can be 2 here, but 2, 1, 3, so it should be 4. And other numbers, we can just put them here. Here we have 1, this one is 2, this one is again 1, 2, 3. Let's say it is 4, and 3, 4, 2. It can be 1. I can write here, for example, 3. Okay. All right. That's very easy question. Rifat, can you read the question and let's discuss this together, or maybe we get first you try this and after that we can do this. It's also a very easy question. Rifat, read it.
Okay. A, B, AC, and BC are the diameter of 3 circles shown on the diagram. Given that AB, BC is equal to 3 by 2, what percentage of the largest circle is unshaded?
What percentage of the largest circle is unshaded? As you see here, we have a big circle. From this big circle, we are just cutting out 2 smaller circles. One is the smallest, another one is a bit smaller. So the question is, what percentage of the largest circle is unshaded? That means that we need to find the area of the cut off or removed part as a percentage of the big square. Anyway, I think the question is clear. It's a very easy question. Aya and Rifah Murad, try this. Let me give you like 2.5 minutes. And come on, guys, you should be able to solve this question. Rifa, what did you get?
I remember something like that, and the answer was 52%. But I don't know how did I solve it.
Really? When did you solve?
Yeah, I got 52%. Like not now, like once, not in Singapore, not in even in this Sasmo, not in this
You are saying
presentation.
that you solved similar question before?
Yes, yes, yes. And I solved it. I remember, but I don't remember how I solved it.
Then you
No,
just
really, I swear I have seen similar to this. Like exactly same, but different numbers.
but your answer is correct. The answer is 52.
Yeah. But I don't remember how.
Ayan, how about you?
I don't know how to solve this other than guessing it.
But why you don't know? Did you understand the question, Ayan?
Yeah, but I don't know
What
how
did you?
to use that ratio to
Yeah,
find
here
it.
the question is what percentage of the largest circle is unshaded, right? So that means I suppose that here how many different circles we have? Three. Let's say the biggest one is, let me just label this by A3. That's the biggest one. And the second biggest one is A2. And third one is A1. So now what is the question? What are we trying to find here? What percentage of the largest circle is unshaded? What percentage actually? This A1 plus A2, right? That's the blue shaded area. They are unshaded. That is the sum of the areas of the smallest and the second smallest one over, right? And out of what? The biggest circle, that is A3, right? And times 100%. The question is this, what is this? Right, this one is the unshaded region of what? The biggest circle, and express this as a percentage multiplied by 100%. Now in the question, it says that AB to BC is 3 to 2. That means that if AB is equal to 3x, then BC should be equal to x, not x, 2x. BC equals 2x. Then what is AC then? AC will be equal to 3x plus 2x, that's equal to 5x. And if you are given a diameter, let's say diameter, okay? This one is a diameter. What is the area of the circle? It is pi times d over 2 squared, right? Because d over 2 is just r squared. So AB is the diameter of that circle, the second biggest circle. BC, the diameter of the smallest circle. AC is the diameter of the biggest circle. So now from here, let's find A1. What is A1? A1 is pi times, A1 is pi times the smallest one is BC, right? So that is 2x over 2 squared because its diameter is 2x. And how about A2? It is pi times diameter. A2 is, it is 3x over 2 squared. And how about A3? It's just equal to pi 5x over 2 squared. So now if you just simplify this, here we have pi times 2 over 2 is just 4. I mean 1. So here we have x squared. Second one is pi times 9 over 4 times x squared. The last one is pi times 25 over 4 x squared. Now if you substitute here, what is A1? A1 is pi x squared. How about A2? Pi times 9 over 4 times x squared over A3 pi times 25 over 4 x squared. And here we have 100%. As you see here, pi is a common factor. I can divide numerator and denominator by pi. X squared is a common factor. And here we have, what we have here then? Here we have 1 plus 9 over 4 over 25 over 4 times 100%. And if you multiply numerator and denominator by 4, so here we have 4 plus 9 denominator 25 times 100%. 100 over 25, it is 4. 4 times 13, that's equal to 52%. I'm just
I
explaining here, but actually when you're doing yourself on your own, you can do much, much faster. Yes, I am.
so you cancel the pi's and you cancel the x squares. So at the top you should just have 9 over 4. So why did you put 1 plus 9 over 4?
Because here, Ayan, here, pi is a common factor. X squared is a common factor. If you just take them out, what we have here? 1 plus 9 over 4, right?
Oh, okay.
That's it. So, Rifa, your answer is correct. It is 52. I hope they will ask similar question. Rifa, you can remember and just circle them. All right, let's move on to the next question. That's interesting question. Murad, are you here?
Can I see the answer? I solved it. It's easy. It's very easy.
First, can you read it? Rifa, first, can you read it?
Yeah, okay. What's the largest number of statements below that can be true at the same time? So the answer is 2.
2?
No, not 2. 1 minute.
Because here it says that the largest number, right? Maximum number of statements, not
Yeah,
minimum.
1 minute. Anthony is lawyer. Anthony is lucky man, but he's not a lawyer. Anthony is a lawyer, then he's not a lucky man. No, it's 2. The answer is 2.
I think it's 3.
Why? For example, let's take Anthony's lawyer. Anthony's lawyer, then no, it's 3, yeah.
Because it says maximum, right? For example, this one, the first one, let's say this is true. Also, the second one can be true, right? Because they are not dependent on each other. Anthony can be a lawyer and he can be an unlucky man. It is true. And if it is unlucky man, that's Anthony is a lucky man, it should be false. And if Anton is a lawyer, then he is not a lucky man. So if he's a lawyer, then he is not a lucky man. That means that he's unlucky man. That's also true. And is a lawyer, then he's lucky man. It is false. As you see here, at the same time, we can have 3 statements true, right? This 1 to 4, they can be true at the same time, right? They are not contradicting each other. Because here they are asking the maximum. So we are trying to find the maximum number of statements that they can be true at the same time. So the answer is 3. Okay. Next question. Rifa, read the question.
Yeah. 4 circles are drawn on a flat surface. What is the greatest number of regions that can be formed on the surface?
Rifa, when you are memorizing, because I think you are good at memorizing, okay? You should memorize
No,
well.
absolutely not, teacher. When I was in lower grades, I have never learned like some texts or something like that. Like I can't remember them. If some numbers, maybe, but not at all. Like with low chance.
Rifa, what I'm trying to say here is, actually, there are a lot of similar questions in Sasmo. Sometimes they just modify the question, change a little bit, and ask again. But in one question, for example, this is S1, right? In S2, they ask like this. Instead of flat surface, they say the rectangular piece of paper. Because here, if they say rectangular piece of paper, the answer will be different, okay? If the flat surface, it doesn't have any boundary, right? The question is a bit different. I mean, you need to pay attention to every detail if possible. Anyway, guys, now try, okay? Let me give you 1 minute and 30 seconds, and after that, we'll discuss. Very easy question. We did similar questions before. Let's see who can find how many different regions. Rifa, what did you get? Ayan, how many regions could you find or could you make?
I'm not done yet, but I drew it once and I have 12, but I want to redo it to see if I can find more. But so far I have 12.
I see. Okay. Rifa, how about you?
I also found 12.
Really?
Yes, but I think I'm confused. I think I can find more.
I
Murad,
have
how about
13
you?
now.
Yes, Ayan.
I did it again and I have 13 now.
Ayan, are you also including the region outside the circles?
No.
Why
Then
not?
it's, I don't know. I forgot about that.
Yeah, actually, that's the important point, That's why they asked this question. Because here it says region, right? Suppose that we are playing a game, okay? In a game, for example, we are going to draw 3 circles so that I'm going to make maximum number of regions. So that in each region, one person will actually stay in each region. At that time, how many people can be involved in this game? It is 14. Why? As see here, the first circle, it is 1. To create the maximum regions, actually another circle should intersect this circle at 2 different points, right? So the second one will be this. And the third one, of course, it will be this. And I need to draw one more. Where can I draw this? Maybe it is here, right? It doesn't look like a circle, but suppose it's a circle. Now, if you count this, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What? Did I miss any? Oh, one more, right? Here we have 13, right? The small one. And outside we have 14. If you draw nice, maybe you can see much better. All right. So as you see here, we can make 14 different regions. One person, he will be maybe a guard outside, okay? And other people, one person standing here, another person here, and another person here. Okay, because there's a logic behind this. That's why they ask question here. Rifa, do you agree with me, with us?
Yes,
So how many, Rifa?
14.
Very good.
One is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. Yes, 14.
Good. Of course, when you're solving in the exam, not dot, if you just put numbers, you don't get confused, like 1, 2, 3, 4, 5, easy to count. Anyway, so the maximum regions we can make is 14. How about this question? How many triangles are there in the diagram below? We just actually did different forms of this kind of question, right? How many squares, how many rectangles, but here, how many triangles? Before we start, Ayan, can I ask you a question? And how actually are you going to calculate this? Using what method here? Or how are you going to calculate the number of triangles here? Can you just tell me the method that you're going to use here?
I just count them.
Yeah, me too.
How?
Is it a special method that we're supposed to use?
Yeah, we are going to count, but how?
First, you count like the obvious ones, the tiny ones, and then you count the bigger ones, and then the biggest ones.
Very good, very good. In this
Teacher,
kind
I
of questions,
counted.
Ayan, if you calculate like this, triangles that contain only one part, triangles that contains 2 parts, and maybe 3 parts, okay, and 4 parts,
Teacher, I found
maybe 5
30. Is
parts,
30
and 6.
correct?
How many?
30.
Yeah, that's correct. How did you find this?
I just counted. I don't know how to explain it.
Let's just count in this way. Rifa. Actually, how many triangles do we have that has only one part? That is 1, 2, 3, 4, 5, 6, 7, 8. They are symmetric, so here we have 16. And how many triangles we have that has 2 parts? That is 1, 2, 3, right? And after here we have 4 and 5 and 6. And also vertically, it is 8, 9, 10, 11. Is 11? 10, right? It is 10. It's 8, 4, 4, 2. It is 10. So here we have 10. Okay, two parts. You can see it, right? See it, right? The triangle which is formed by two triangles. How about three parts? For example, this. It doesn't form a triangle. This. I think three parts, they don't form any triangle. How about four? Ayan, can you see any triangle that contains four parts?
Well, there probably are some because you have 30, but I can't find them.
Can you see this one?
Yeah,
Right? And also upper part, right? Also the same thing. It has this one, right? And how about if I start, for example, we have two. Do we have two more? How many do we have here? It is two, right? Four part. It is two or four. That's one. Can you see other four? And also this one, right? If you look at this, one, right? Or one. So here we have five parts. It's one, two, three, four. So that is four. So altogether we have 30. We don't have any triangle that contains five parts or six parts or seven parts, right? We don't have that big. Good, Rifa, you are correct. You are so fast. Rifa, can you read this question for us? And let's see now about this. What is it? It's about the statistics.
Okay. The statistics. Okay. The bar chart below shows the number of cars sold in town A in the first half of year 2015. For example, 4,700 cars were sold in January, while X thousand cars were sold in February. The number of cars sold in June is double the number of cars sold in February. The average number of cars sold in each month is 5,400. What is the percentage increase in the number of cars from May to June? Round off your answer to the nearest whole number. For example, if your answer is 9.56, then write your answer as 10.
This kind of questions usually, Ayan, Rifa, Murad, statistics question. And actually they ask in this way because they have to explain everything. Okay. But mathematical solution usually it is not so hard. It's so, let's say, not so easy, but it's not so complicated. Because statistics, it is a branch of math, but they don't involve a lot of calculation. Okay, very simple. So if you look at the graph, what is it saying? It's saying that in the question, right, we are talking about this graph. As see here, number of cars sold in over the last 6 months. In January, in thousands, how many cars were sold? 4.7 thousand, that is 4,700. In February, X thousand cars. March, 3.35 thousand cars. April, 5.6. May, June. And also in the question, it says that the number of cars sold in June is double the number of cars sold in February. What does it mean? It means that here, June, it is Y, in February, it is X. So Y is equal to 2 times X. This is how they are related to each other. And also another information, it says that the average number of cars sold in each month is 5,400, right? And how do you find the average? Sorry, how do you find the average? The average is, let's say it is mean. We call this mean in statistics, or just average value. Just we need to add these values, right? That is 4.7 plus X plus 3.35 plus 5.6 plus 6.9 plus Y, and over 6 months, so divide by 6. That's equal to how much? 5,400. So that is 5.4 thousand cars. Yes, Ayan?
Mr. Chasm, but you can't solve it this way because there's x and y. But if you write instead of y 2x, then maybe you can solve it.
Yeah, I'm going to put this first. I'm going to write this expression. After that, I will substitute 2x for y, Ayan.
Okay.
If I write, for example, Ayan, at the beginning, if I write here, if I wrote, for example, 2x, maybe Rifa would ask me a question, Mr. Carson, why did you write x and 2x? Okay, first let me just write y, that represents the number of cars sold in June. And after that, when I'm solving this, I can simplify this. Now here, 4.7 plus 3.35 plus 5.6 plus 6.9. And we know that x plus y, that's equal to 3x. That's equal to, take 6 to the right-hand side, 6 times 5.4 minus, what is the sum of those numbers? It is 4.7 plus 3.35 plus 5.6 plus 6.9. That's equal to 20.55, right? So from here, what is x? That is 6 times 5.4 minus 20.55 and divided by 3. So the answer is, what is that? 3.95. Now from here, then we can get the value of y. We need y, right? Not x. So what is y? Y is 2 times x, 2 times 3.95. That's equal to 7.9. Because 2 times 4 is 8. So just minus 0.1, that's 7.9. So what is the question? It says that in the question, what is the percentage increase in the number of cars from May to June? So in percentage increase, how do you calculate this? In actually now we know the value of y, that's equal to 7.9. Actually in May it was 6.9 and it increased to 7.9. To express the increase as a percentage, first we need to find the difference, 7.9 minus 6.9 and divided by 6.9 and multiplies by 100%. That gives us the percentage increase, right? So which is equal to 7.9 minus 6.9, that's equal to 1. And just we need to divide 100 by 6.9, which is equal to 14.49. That is 14.49. But it says that, let's see here, very close. It says round of your answer correct to the nearest whole number, so that our answer is dot 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 the 14%, because this one is less than 50, right? Any questions, guys?
No.
Good. It's not so difficult question, but now, as you know, Ayan, Refa, Murat, I don't know if you have ever heard about this. Now, these days, data science is a new field, not new field, maybe newer field, let's say, comparing to other fields. And in the US, for example, there are a lot of universities offering this major. Okay. Data science means you are studying statistics together with math, I mean, algebra, and also computer. And combination of these three things, they are called data scientists, because you are dealing with data. How? Using some computer science software. And to analyze data, you need to have some knowledge about statistics. And that's why actually now a lot of schools, they are starting to offer statistics in depth, so that students should start learning statistics from the early age. From the early age means from maybe primary school even, step by step. Anyway, let's move to the next question. A prime number p is a Sophie-Germain prime if both p and 2 times p plus 1 are prime numbers. Number 5 is a Sophie-Germain prime since both 5 and 2 times 5 plus 1, 11, they are, what is it, prime numbers. How many Sophie-Germain primes less than 60 are there? Guys, let's do this question together. We don't have any general formula to answer this kind of question. And if you ask me, Mr. Carson, why are they asking this kind of questions? They are measuring, okay, your thinking skill, number one. And if you have new concept, can you understand this fast and immediately make use of it? Okay. And also another one is, how fast can you think? Okay, that's why they are put here, because these things, you never learn this, you never study this at school. So now they are giving a definition, and using this definition, can you just answer this question or not? It's not so hard, but it's new. The Sophie-Germain prime, I don't know if you have ever heard about this number. Anyway, it says that primes less than 60. So that means that immediately we need to write all the prime numbers less than 60. And after that, among this, we are going to choose the numbers, prime numbers, which satisfy this condition. So what are the prime numbers less than 60? They are 2, 3, 5, 7, 11, 13. And if I miss any, let me know so they will not make mistake. After 13, what is it? It is 17 and it is 19. The next one is 23. And next one is, what is it? 29 and 31, 37, 41, 43, 47, 53, 59. And these are the prime numbers less than 60, right? So now, when you just multiply by 2 and add 1, is it the prime number or not? 2 times 2, 4, 4 plus 1, it is 5. It's a prime number. 3 times 2 plus 1, it is 7, prime number. 2 times 5 plus 1, 11, prime number. 2 times 7 plus 15, it is not. 2 times 11, 22 plus 23, it is prime number. 2 times 13, 26 plus 27, it is not. And 34 plus 55, it is not. 38, 39, it is not a prime number. 46, 47, yes. 58, 59, yes. And 62, 63, no. 74, 75, no, it's not a prime number. 82, 83, 83 is a prime number. And 86, 87, 87, no, because it is 3 times 29, right? And 94, 95, no, divisible by 5. 53, 106, 107. 107 is divisible by 107. Is it divisible by 7? 37, 49, 17. I think it's a prime number, right? And the 59 times 2, it is 118, and the 119. 119 is divisible by 7. 7 times 17 it is. Yes, that's it. So how many? 1, 2, 3, 4, 5, 6, 7, 8. So here we have 8 such numbers less than 60. Okay. Good. Ayan, Rifa, Murad, thanks for your time, attentions, and patience. Okay, keep practicing. We have only 4 weeks left. And if you get a good result, you will make your parents happy. And also you will be happy. And you will be proud of yourself. And that means that, I can do something. And it gives you some self-confidence. So try to practice only these questions, okay? If you need more questions, just let me know. I will give you new papers, all right? Have a good night. Enjoy your holiday. I will see you on Friday, guys.
See you.
Okay.
Bye. Have a great time.
Bye-bye.
Bye, Mr.